Welcome to our presentation showing the design of a roll cage in BendTech software. In just 15 minutes we will start with nothing and design an entire cage, which includes a total of 18 parts. We will then take a quick look at a few dimensions, BendTech bending instructions, as well as fish mouthing instructions and templates. Sounds like a lot we have to do in such a short period of time, so let's get started. At the beginning of each part definition, we will show a thumbnail of the entire assembly. The part we are about to work on will be shown in bright red. Our first part is going to be the B-pillar. Parts are defined in 3D space using left, right, front, back, floor, and ceiling. The single part interface allows us to create points in up to 3 different directions at one time. We have started by defining our base points of our first pillar. Next, we are going to define points by using angle. We can select the quadrant, angle, and distance. Back to single, and we're going to create 2 more points towards a ceiling of 16 inches. To create the part, we select the bent part icon from our main. The software asks for the number of bends. It is 4 in this. Continue by selecting the points in sequential order to define our part. We give it a part name of B-pillar. When we are finished, BendTech adds the radiuses and we can shade our part. We are now going to define our 2 uprights. Same as our B-pillar, we define points to create the part. Our base point is 36 inches away from our B-pillar. Our first bend is 1 inch towards the back and 8 inches towards the ceiling. BendTech will automatically calculate our bend angle or any rotations that might occur. Our next bend is 2 inches to the front and 24 inches towards the ceiling from our last bend. Our last bend is 1 inch towards the back and 40 inches towards the ceiling from the, as well as 5 inches towards the left. We will now define our upright with 3 bends. Using the mirror function will easily allow us to define our upright for the left side. Now we will create our C-pillar. Our C-pillar base will be back 30 inches and up 16 inches from our B-pillar base. The C-pillar will rise 22 inches as well as pitch 3 inches towards the front. Again, we will select the points in sequential order to define our C-pillar. We will now create our 2 pillar supports. Our pillar supports will be located 3 inches from the tangencies of the bends on the B-pillar and the C-pillar. Our bend will be 12 inches back from our B-pillar. Define the pillar support by selecting the two endpoints and the bend point. We will now use the paste part function to define our second pillar support. We will now define our lower door bars. Two-point function allows us to select 2 points and then define how far down that line to create our new point. The plane function allows us to define the direction of a plane and intersect it with a line to create our new point. Now we will define our bend locations for our lower door bar. Again, we will use our paste part feature to drag our second lower door bar into place. We will now define 3 cross members by using straight part. We will now define our seat risers. We will start by changing our 1 3/4 inch DOM material to 1 inch. And we will also need to change our tool. Again, we will go back and define a few points to create our part. To define our left side riser, we will again use the mirror function.